So is it going to be the ultimate SIG P-320? We'll have to wait and see. I got it for a totally different reason, which I can't really talk about yet, but for now I'm just going to do as much as I can to it, and we'll see how it turns out. Alright, so I just picked up a SIG P-320. These things are pretty sweet. They're pretty customizable on their own based on their modular design, but I'm going to do a bunch of stuff to it. I got a Trijicon RMR I'm going to put on here. I'm going to mill that in. I'm going to do a bunch of slide milling. Got some suppressor height sights. Got a bunch of different grip modules to try out. Probably do a little trigger work, put some Cerakote on it, and we'll see what else we can do. Alright, here's a slide. It's going to be a little bit trickier to mill than, say, a Glock slide, just because it's got a bunch of interesting angles and tapers. It kind of tapers here, and it's got this little flat here. And on the inside, it's got a lot of little recesses and other cutouts. So I want to model it pretty accurately because I don't want any of the windows to, cut through a rail or something like that. So I'm trying to measure everything as best I can here. Side note, if you don't have gauge pins or gauge blocks, get a set. They're pretty handy. Pretty confident I got everything within about a thou or two. So I'm using Fusion 360 to do the CAD and CAM. And I'm not going to walk through too many details on the modeling of the slide itself, other than the fact that I use a lot of lofts and sweeps to get some of those angles. I'll do more of a step-by-step when I start modeling the mount for the Trijicon reflex sight. Okay, now that we got it modeled pretty accurately, first thing I'm going to do is mill a mount for this Trijicon sight. So as you can see, the problem is right now, there's no way to mount it. The Trijicon has these little holes here for a 632 screw, and it has this footprint. So we need to mill a little cutout so that it gets recessed down flat. Rather than measuring everything, I emailed Trijicon to see if they'd send me a blueprint, and they were cool enough to send me this PDF. Alright, so we need to create the pocket for the RMR. So the first thing I'm going to do is I'm going to create an offset plane, and I'm going to key off something like a known distance. So I'm going to key off the bottom of the slide. And this doesn't really matter yet where the position is. I'm just going to move it up here. Okay, next we need to create a new sketch, and I'm going to pick that plane. Alright, so I like working in this a little bit. So I'm looking at the top now, and one of the first things I'm going to do is I'm going to create some reference geometry. We're going to use some more snaps and draw right down the center, and I'm going to turn that to a construction, and I'm also going to lock it because I don't want that to move around on me. So what's next? We're going to create a rectangle. This is going to be the rough outline of the RMR. Doesn't really matter the size. Now we're going to create a couple points on there. Put them anywhere, and now I'm going to make sure that those are set to the midpoint. Alright, so now I know those are locked to the midpoint and they're never going to move. So now let's actually set these to be coincident with this, and now we know that this is going to be locked center and it's not going to move on us. Alright, let me just temporarily lock this into place here. I'll set to like 0.1. Again, I just don't want it to move around on me. And let's start dimensioning this out. So based on the specs, the RMR is, the length is, so I hit D for dimension, and I'm going to set the length. It calls out 1.78. And for the width, it's calling out a 1.1. So that's the rough footprint there. So now we're going to create another line. This one's just going to be just kind of helper geometry. Make sure it's vertical. And I'm going to turn it into construction line as well. And now we're going to create the arc. There's kind of like it's a big radius from the front of the RMR. So we're going to go sketch. There's a bunch of ways to do this. It's just the way I happen to be doing this one. I'm going to do a 3-point arc. I'm going to click right there. Click right on the intersection there. And right on the center point. Okay, so now we have an arc. Now let's go ahead and dimension that out. And it calls out a 3-inch radius. And it looks a little weird, but it did it properly. So you can see it right there. And I'm going to go ahead and hide the bodies so you can see a little easier what's going on. Okay, so there's our basic rough outline. Let's add some fillets now. And right click, mouse up to repeat. Do the same thing here, 0.13. And the front are a bit smaller, those are 0.5. So fillet, I lost my repeat. So click here, and then again, make sure you're clicking on the actual arc. And we're doing this at 0.05. Cool. Same thing here. 0.05. Okay, that's our basic footprint. Now let's start creating the little other elements. So we're going to go create a circle. This is going to be the little boss. It's like a locating pin boss. Let's not worry about the size. From the back of the RMR, the call out is 1.625. And from the center, it's 0.443. All right, next we'll make the hole for the screws. Temporarily place it. We'll do the actual sizes later. And these key off of that boss location. So the distance is 0.875 and that value is 0.073. Okay. So now the radius here, this is a threaded hole, so it's going to be 0.1065. It's going to be a 632 thread. And the call out for this guy is 0.1539. All right. So let's click those and let's mirror them. Click our mirror line, and there you go. So that's our basic footprint for the RMR. Okay, so what I'm going to do is I'm going to turn the body back on. And we're going to go back here. My fusion's a little messed up right here, but I'm going to go back to the plane, the offset plane we made. And you're going to edit the feature, and we're going to move it down. All right, I'm just kind of arbitrarily moving it down. We'll pick the right height later. That looks good. So I'm going to hide the body again. I'm going to select everything. And I'm going to turn the body back on. And I'm going to press pull. And I'm going to pull it up. All right, so that basically just cut our slot. I'm going to go back down to the sketch, turn the sketch back on. And if we want, we can select those holes. And we can pull those down however far they need to be. I'm just going to say 0.015 right now. I got to do a little more exploring and see what's under here, make sure I'm not cutting into anything that I shouldn't be. But I don't think I am. So, okay, I'm just going to do a quick hack here. So the height of the bottom of the Trijicon is 0.345. So I'm just doing a quick hack here. I'm going to grab this. I'm going to press pull. I'm going to pull this up minus 0.345. Now I just kind of want to see if I'll be able to co-witness through the sights, because I mocked this up too. This is what, how tall the sights are. So it looks like you'll be able to see right through there at this depth. So that should work. So let me undo that. So now basically with the Trijicon sitting flat here, you should be able to co-witness through it. Okay, off camera I cleaned this up a little bit more. Did a few more checks to make sure some of the screws weren't going to penetrate this hole here, and I kind of perfected the position I wanted for the co-witness. I got the depth pretty much where I want it. Got it pretty much almost in line, kind of on average with this line here. Also just added these little nubs back in. That'll help if you drop it or knock it. These will keep it from pivoting. Left a little gap here so I can still fit a 1/8 inch end mill, and there should be enough still to kind of locate and hold it in place. Okay, let's jump into some CAD. We got to make the stock. Basically, so what I'm going to do is I'm going to jump and grab the slide. I'm going to copy it, and I'm going to paste new. Paste new will make a copy of it that basically isn't connected to the old one. So it takes a little minute because there's a lot of operations going here. All right, so now what I want to do is I'm going to go to the new one. I'm going to call this stock. and I'm going to go and activate it. I can do this a couple ways. I'm actually just going to go into my timeline now, and I'm going to back up a ways, basically until I erase here. Let's see, I'm going to just select all those and delete them. Okay, now I'm going to hide it, and I'm going to go into cam. Actually, I'm just going to activate that for the heck of it. Now I'm going to go into cam. Then I'm going to go into setup, new setup, and let's switch the stock from relative box size. Let's choose a solid. Turn our new stock back on and select that. And now we can hide it. So as long as it's modeled accurately, that should be pretty good representation of the stock, which is the unmilled slide. All right, so now we need an origin. To do that, I'm going to go back to model, and I'm going to create another offset plane. And we're going to move it up to, it's going to be at the top of the slide, negative 0.867. Okay, and it's going to create a new sketch. And real quick, just to be clear, what we're doing here is I want my origin, my G54 basically, to be this right at the top center on this face. So first thing to do is select that, and I'm going to go sketch, project, and that'll project it onto my sketch. I'm going to go back in the top view, and we're going to create a point right there in the center. And that point, I just want to double check and make sure it's dead center. It is. Okay, good. That'll be my origin point. So I'm going to go back to cam and go back to our setup, and let's choose, instead of stock box point, let's choose selected point, and we can choose that right there. So as for our model orientation, let's choose Z axis plane, Z and X, and we can choose this as our Z, and then we need to find something for our X that is the right direction. And there we go. So now we've got our XYZ G54 set up. So this video is getting a little long, so I'm going to run through the cam really quickly. So I'll start off with a 2D adaptive using a 1/8 inch end mill and a 2D contour, go around all the edges. This cuts it to the nominal size of the actual Trijicon. Then I do a horizontal just to clean up the floor. And carbide drill, followed by a thread mill. See a little corkscrew there. Then I put a manual stop here because what I want to do is I want to test fit another 2D contour with a negative stock to leave, just to open it up a little bit more. And if I need to, even further with the second one. So here's what the simulation looks like. Here's the 2D adaptive, just kind of takes out most material. On the contour, little floor, horizontal on the floor, carbide drill, thread mill, and the other little expansion contours. Just gotta knock the sights out. Didn't have my gunsmithing tools, so I used a wooden dowel so I didn't mar it. Put in the vise, use the Heimer to find the Y0. So I started on the front, moved to the back, zeroed those, and then just basically divide by 2, and that'll give you your Y0. And once you have your Y0, you're going to move to the 0 position, and then move down to Z, and get our Z. Then get the X. This is 2D adaptive. It's a Lakeshore carbide 5-flute end mill, carbide end mill. This is 5100 RPMs. 0.02 step over, and 14.5 inches a minute. I'm not exactly sure what the material is. It's stainless steel, I know that for sure. I'm not sure how hard it is. I know it's hardened. I'm using Lakeshore Carbide's suggested speeds and speeds for hardened stainless steel. So I just did the horizontal using the same speeds and speeds. I'm going to drill the holes for the 632 screws with the Lakeshore Carbide carbide drills. These things cut freaking smooth. This is the first time I ever used them. Alright, next I'm going to thread mill again with the Lakeshore Carbide thread mill. This is a 632. I'm cutting them in 3 passes at 3000 RPM, 3.6 inches a minute. First hole is going pretty smooth, finishes nicely, has a great fit. The other hole didn't go so well, you'll see here in a second. I think I have too much run out in the holder. I think I have about 1.5 thou run out in the holder, which is a lot for how little this is cutting. Price, again, the nice thing about thread milling, you're just going to pull that little chunk out. You don't need to drill it or fight with it or anything like that. You never ruin a part with thread milling. Alright, one last 2E contour to open it up a little bit. I'm using a negative stock to lead of about 2 thou. Just going to open it up a little bit more for the coating, you know, the ceramic coating on the actual Trijicon. After this, it's going to have like a perfect tight fit. Okay, there it is mounted. The dot looks really big in the video, but it's actually a pretty small dot. Just kind of blurs and looks bigger. But it's mounted, it's in there rock solid, and it has absolutely zero play. So it'll stay accurate even if it gets loose. I put the sights in a little bit because I wanted just to verify the co-witness, and it looks perfect. Alright guys, thanks for watching. I haven't done a video in a while, so I figured I'd just record the progress on this. I hope it wasn't too boring. Next time we're going to basically be cutting out a bunch of windows and slots in here. It's going to be a little tricky trying to find a design that works with this particular slide, but I think it'll work out pretty well, so see you next time. Also, if you're interested, hop over to my Instagram. It's just S2Jesse. I post there pretty frequently. All kinds of random stuff from guns to cars, special effects, prop stuff, knives, machining, name it. Just love making things, learning new stuff, and just all about challenging yourself.